So now we will go into Cecilia Conde's presentation, and after her presentation, we will open a round of questions and answers for all the audience. I will introduce Cecilia Conde, of Climate Change Adaptation of the National Institute of Ecology and Climate Change of the Ministry of the Environment, Semarnat. She's also researcher, part-time researcher at the Center of Atmospheric Research of UNAM. Cecilia Conde obtained a PhD in Earth Sciences at UNAM and is specialized in atmospheric issues. She has an MA in Geophysics at the Faculty of Sciences of that institution. She's a specialist in impact, vulnerability to adaptation and climate change, and climate variability, specifically in agriculture in Mexico. In her research, her research has involved the possible effects of climate change, emphasizing on adaptation as a response to that change. That was the case of studies carried out with maize producers in Tlaxcala and coffee producers in Veracruz. She directs PhD studies in different areas, and she has a strong drive towards interdisciplinary research. In 2011, she was awarded the Ecological Award by the Ministry of the Environment because of her contribution to climate change studies in Mexico, her scientific trajectory, and her role in the different reports. She's collaborated in different areas of studies vis-a-vis the framework in the UN, and she's also advised different governments in their climate change plans for action. So thank you very much for the invitation. It's good to come to the celebration of the 75th anniversary of the COLMEX, and it's highly relevant for research and studies and the policy implementation aimed at reducing vulnerability and increasing adaptability. With INECC, who is also here at this event, we have worked for more than a year to try to create an accessible portal with all the basic and necessary information. It is information, the information we have is not very dynamic yet. We just have PDF files or the shake files of some figures. But the idea is to have a portal where officially we have information and access to information for climate change studies. So without much ado, I gave this title, Vulnerability Indicators to Climate Change, just to say whether this is a question of opinion. And this in terms of decision-making, which is the hat I'm wearing right now. Well, it's 80% of the hat that I'm wearing today. This is essential, actually, because out of an analysis, a study, we be told that these are vulnerable areas, and other studies say that they're not vulnerable. And that is important because we do want to move forward, as of now, to follow up the national strategy for climate change, the climate change law, and the special program and the new documents, and we want to move towards increasing our adaptability to climate change, which we are currently undergoing, and this is a fact. So let me see whether she's trying to change the slides, and she managed to. I'm going to present some climate change scenarios and the work that we've been carrying out, because this is part of, this refers to very specific points. of what we will be specifically presenting in different workshops. An interesting thing about the scenarios here is that after having constructed these scenarios, the climate modulation group that comprises INEEC, the Mexican Institute of Water Technology, CICESI in Ensenada, the atmosphere sciences at the UNAM, and other bodies, we are currently discussing how to model climate, but also how to produce useful information for impact, vulnerability, and adaptation studies, which are not the same. We can do atmospheric studies and discuss what elements a climate model should comprise, and when we change the greenhouse gases and whether this has to do with the physics or the chemistry of the atmosphere, and something else to say, I'm going to generate useful information for those that will carry out studies. That's why this climate modeling group was created. When we had the results, we realized that we were also comprising Central America and part of the Caribbean. And this has allowed this climate modeling group to include colleagues from Central America, Cuba, Dominican Republic as well. So we carried out a workshop last year. We'll have another one this year and another one next year to exchange, to see whether the tools that we have presented are actually useful. I will try not to take up too much time. Before talking about general circulation models, a very important theme regarding climate change is to detect where and whether there are observed changes. This is highly important to carry out a very rigorous study, not only to see how temperature is increasing year by year, but to know that if it's actually increasing or not, and whether there are structural changes. Breakpoints too. So this is included in these detection graphs. Most of this work was Netofis and Dildal Center, but we had to do with this by agreeing with this analysis. So this is how the special climate change program starts, by diagnosing vulnerability and adaptation. So there are important observed changes that allow us to know that whether together with these observed changes, there are observed impacts and attitudes changes within society resulting from these observed changes. So these are spearhead studies of high importance because we need to be discussing what is happening now in the Mexican territory rather than discussing what will happen in 2100. This person Diaz carried out this analysis of the temperature trends and also extreme events and what will happen with these extreme events in the future. This is a very delicate study too, because we're talking about daily data towards the future and what would happen with temperature beyond certain critical levels. But this is also highly important information to know under what conditions we might be in the near or distant future. The next slide, I have to point over the computer? She's just asking. The next slide is this page of scenarios. These are, you can't see the address. It's the result of these academic institutions reflected there, and you can also see the sponsors. This is interactive. You can choose a region, you can choose the different variables, etc. This is a web page. It had a lot of accesses, but the problem is that our infrastructure in INECC is not very good. We don't have enough speed. So cyberspace sometimes betray us. You're downloading data and there's a sudden breakage. There was also the problem that people would access and they wouldn't understand what we meant by metrics, what is this information you're providing. So we saw some deficiencies that were pointed out to us, and we did 4 different regional workshops. people would even tell us that the colors were wrong, the scales were wrong, what does this mean, what does this unit mean? So we learned from these workshops, and this year, well, this is the kind of data available on this web page with a half a degree resolution, the mean extreme temperatures, only 2 futures, a close and a far away future, and 3 of the RCPs that Brian already mentioned, which have to do with climate change, i.e. if the climate change was forced with these watts by square meter, which is what 6.85 means, etc. So we worked on 15 different models, general circulation models, and we weighted these 15 models. It's very difficult to tell a user to manage 15 models every month, 2 different futures with 5 variables. So people say, well, in the end, what do I do with all this? So a proposal is called averaging based on the performance of the model per region. Those that do well have greater weight than those that do badly. Unfortunately, there's not a perfect model for the whole of Mexico, so it does depend on each region. Each model has different performance per region. This is explained on this webpage. And you can't see the logos. This last year, 2014, towards December, having seen that the users were struggling with this web page, we decided to develop with the Mexican Institute of Water Technology something that would allow the users, by accessing the page, to have videos to explain the usage of this web page. So we think that this does help people find the information available on this webpage useful. And part of the information in this work that IMTA carried out is to identify where the different information regarding climate change scenarios is in Mexico and also internationally. So it would seem as if there's only one way. So I can explain to the users that other institutions have other sources of information. These are important sources of information. Our work is to introduce this information regarding climate change and to present this to the people. I'm going to rush in this area so I can move forward. With CICESE, we also worked on other variables that the users in these 4 regions, the north of Mexico, the Yucatan Peninsula, etc., requested. And it's that there are no ocean variables for a country that is surrounded by coasts. It's important to know what's happening at an ocean level. We have included this, and we have also included some first scenarios regarding an increase in the ocean levels, the sea level, which comprises important variables. What we incorporated was rainfall, surface temperature, pressure changes associated to the wind components with these horizons and these models here. So let's show you an example. This is possible results with the different models. An increase in the oceans, the sea surface temperature shows how there's a warm water pool in front of the Mexican Pacific, which is intensifying, and that is very important for those that want to know what will happen with the rainfall levels in the future in Mexico. And regarding the sea level increase, these were arbitrary increases, but there were 4 case studies carried out that asked what would happen if there were also tropical storms or Category 5 hurricanes, apart from the increase in the temperature. What would happen with these kind of phenomena? We think these are interesting contributions to the climate change studies in Mexico, resulting from this coordinated work that we carry out. This is a map from UNAM. It is public. These are the 15 separate models. They haven't been averaged at all. And it has a resolution of 30 seconds by 30 seconds. That's the highest resolution that we have. It's public, it's free of charge, and it's, of course, subject to the criticism and the expressed needs that the users have. Potential impacts in Mexico, you would say, well, I have all the possible scenarios and models. Now, what does this imply for Mexico or for the region under study? So we need to try to be more rigorous in order to introduce this information into what we call impact analysis. Is 1 degree the same than 2? Perhaps 1.1 might make a change and might go beyond the critical threshold in different regions and sectors. The summary of the impacts that we have found for Mexico are in the Special Climate Change Program, presented as tables. This is also work with TIMDA and the Met Office. And it says that what would happen for Mexico food-wise, water resources, floods. By the way, we have updated the work carried out by the Met Office. In the case of the coastal areas, the number of stars is the level of confidence of the results that would be obtained taking tools, impact analysis tools, through the author's consensus and the published studies. Can you click on the computer? And vulnerability. Vulnerability. We know that vulnerability is multifactorial. That's no surprise for all of you. So what factors will we be including when we carry out the vulnerability analysis? We need to know vulnerability to what. That would be very good, because nobody is just vulnerable per se. We need to know which is the research question in order to be able to choose the best variables to explain the current state of vulnerability and that allow us to make an analysis of the future. This also appears in this Special Climate Change Program. These are 319 municipalities with greater levels of vulnerability, and the higher the red implies greater vulnerability. And then you have vulnerability per state. The idea was not to say the most vulnerable are in Chiapas, Oaxaca, etc., but to say in each state there are more vulnerable municipalities in order to attribute responsibility to different state governments to reduce the vulnerability levels. So first we have the whole scenario, and then we have state by state. Interestingly enough, to open up the discussion, how did we identify the most vulnerable areas? To start, there was a national climate change strategy that already had ranked municipalities, saying these are more vulnerable, these are less vulnerable. Then there were studies carried out, some by Monterroso. I have highlighted it because I'm going to try to detail it more. And then UNAM carried out another study. There are studies in INECC on the area of water basins and climate change. Dr. Kotlet, who's here, can answer questions later. There are areas of flooding and landslides. And we said, which are the worst or the most vulnerable areas following this criteria, vulnerable to flooding and land wash slides? And then we have the study in 2013 of those that had been in the hunger crusade. Hypothesis is if the studies are rigorous, the results will coincide, because not necessarily the methodology or the database are the same. Some will have 8 variables, 7 to 100 variables. Heaven knows how many variables. It is important to take that into account to see whether there's redundancy or not. But we think that in terms of trying to rank the most vulnerable municipality, these were the sources of information. Of course, we also have Semapred, identifying which areas are vulnerable to what events. Is this good or bad? This is the best that we could have done with the best results that we had. But it's obvious that we do need to promote a model of adaptation and mitigation. INEEC is involved in the coordination that I'm participating in and other coordinations. There's also the Colegio Frontera Norte with Dr. Sánchez and INECC that we had a meeting yesterday with Patricia Moreno and with Isabel Garcia Col and other research of INECC researchers, the Autonomous University of Chapingo, and so on and so forth. So to place up the discussion of how to carry out vulnerability studies, especially what we call social vulnerability. Next one, please. Current and future vulnerability. This is the thesis of Alejandro Monterroso, which is focused on agriculture, and these are the variables that were chosen. So that is what defined the selection of variables for the vulnerability analysis. What is the current vulnerability, and what might it be under different climate change conditions? We think that it has passed some of the filters. Alejandro obtained the award to the best geography doctorate dissertation in 2012. And there I am. We have to show off our good students. It has, of course, also been published. You can't see the reference, but the PhD thesis and the article can be downloaded. The methodology is exposure, sensitivity, adaptive capacity, a little bit in the same lines as Brian was presenting. If I have to analyze vulnerability, you have to evaluate exposure, consider the climate and the environment, sensibility, the systems that I'm analyzing, to how strong they are vis-a-vis climate change and extreme events. And a very strong and important aspect is how to evaluate the capacity to adapt. So we started to create indexes. So we created an exposure index. All these are data at a municipality level. Sensitivity index and adaptive capacity index, and with 2 general circulation models with a scenario of emissions and future climate change and seismic future. That's basically the idea. And what indicators will we use for exposure? Extreme events, drought, flooding and storms and so on, environmental issues, water quality, soil, etc., to have the climate in this region and the modeled climate change. The next one, sensitivity. Here, indicators were in terms of population and health, we will show them soon, and agriculture and model changes. So we carried out the studies on the analysis of temporary maize and what would happen with climate change in the forests and in agriculture. And of course, adaptive capacity in terms of what we call human, social, financial capitals, natural capitals. The next one. Can you present the whole? These are all the variables that were included. Interestingly enough, we can say that in the future, social variables are difficult to project. And this is the importance, I think, of the discussion that we can have with Brian. What we were able to project, or rather he, Monterroso, who graduated, was population and GDP. Because climate, I have scenarios 2050, 2100, but if I want to describe a future world, I would have to say something regarding some of the social and economic variables that are here, and the ones that we might have, because CONAPO, they have projections of these two areas, the GDP and population. Natural capital, interestingly enough, regarding the adaptive capacity, is expressed in terms of forest, reforestation, aquifers, basins, which are the essential variables that you need to take into account when you want to mitigate. If you want to mitigate towards 2020, 2030, say, I'm going to mitigate through reforesting so many trees. If that has been through a appropriate evaluation, this can be considered as an action that has to do with adaptive change. We're all looking for synergy between adaptation and mitigation, because adaptation seems to be one line of climate change and adaptation seems to be something very local. There's not much to say about it. But if you bring them together, mitigation and adaptation, you can bring them together. At least that's what we would have. Landy and I would hope to have that, so we could have a project together. These are the municipal databases, municipal data. And next one, please. And well, after the article that you have to write beforehand, we published one article on exposure, another one on sensitivity, and adaptive capacity is not that easy. The discussions with colleagues is quite difficult, but it's of core importance for decision-making regarding policies. How do I evaluate our adaptive capacity? How can it increase in an uncertain future? Because I'm not carrying out a prognostic for 2100, but I know climate will be more extreme. So what do we have to reinforce of all the variables that have been under discussion? And specifically speaking, what can we do with the adaptive capacity? Next one, please. This is a way in which we imagine the future. This is in the thesis, in the dissertation, and the idea is to communicate future risk, future vulnerability. We say that at present, with data from 2005, which is when the thesis was presented, we could say that out of all the municipalities in Mexico, 13% had low adaptive capacity and a high sensitivity to climate events. That was 13%. So we have these two scenarios, In one scenario, it was up to 38%. The municipalities that had high sensibility and low capacity to respond. And the one is 20%. This is something we can discuss. There's still another one. Can you click on it? If we group them together, we would say there are 292 municipalities in which the adaptive capacity is low, but sensitivity is also low. So perhaps in these cases, there are actions to carry out, such as invest in increasing adaptive capacity. And in the lower extreme, if the adaptive capacity is low and sensitivity is high, it's urgent to act there. And 570 of the municipalities are there. So if I wanted to place the information considering all of them the same and giving them the same amount of money to increase their adaptive capacity, that's one possibility, but I can also prioritize for the urgent situations, thinking in terms of making projections and also training. I would like to present new studies in Mexico. These are the future trajectories. This is the discussion in the context that Dr. Brian presented and what we would like to do. In chapter 1, which I managed to participate as an author in the last report, I don't know whether you have seen these rock-strong works regarding the planet's boundaries. We're going to put an end to water, forests, and we'll put an end to the planet. There are stressors that are making us go beyond those boundaries. One of them is climate change, the other one is a loss in biodiversity, etc. So perhaps we can end at the bottom scenario or the top scenario, but we need to have a discussion and to take political decision-making to define the future trajectory. So we need to characterize this and then create these scenarios regarding what would happen if environmental policies followed this path or this other path in order to identify the future world. And this is the moment. So if we were in the future, well, there's no point. This is a moment to act, and we need to discuss in depth the assessment rigor to the possible trajectories. There would be ideal trajectories, but we don't have the human financial resources. But under our conditions, how can we increase these resources, and how can we choose the future trajectory that we would like to see? So I will stop here. Thank you very much.